Hello, welcome to another briefing. So, in this briefing, I wanted to start out by talking about what's going on satellite, what are we noticing, and how that's affecting our pattern today. What we want to do usually is we look at the initial conditions. Before we get into computer models, it's really important to look at what's going on now with the atmosphere and then understand why, and then we'll look at the computer models. So what we see here, first thing we notice is this big center of high pressure. You can see it marked with the H over here. This is looking at the 500 millibar pressure height. This is about halfway up the troposphere. What's going on gives us a good picture of what's going on with the atmosphere weather-wise, because most of the weather happens in the troposphere. Anyways, here you have this 588 decameter pressure line here. Here's a 584, and so what you notice here is the ridging. You have higher pressure over here building up this way. Now, this is more of what we call a flat ridge. So it's not a super spiky ridge where it's like spiking very intensely, and when that happens, we tend to really heat up. The inland areas get very hot, and even the coast can get a little warm because the fog becomes much thinner. A lot of times it gets completely compressed, and when the wind switches from onshore to offshore, it can get really warm at the coast. But this is more of a flat ridge. This isn't, see, if this were a sharper ridge, we would have the lines doing something like this. But it's a flat ridge, so we actually have more of a subtle increase in heights, as you notice here. There's one here, there's another one here, there's another like higher pressure zone over here. So this is what we call flat ridging. It's ridging. So it's going to be warm to hot inland, but it's not super strong. So you'll notice along the coast, the marine layer is able to still stay pretty active, pretty persistent. You have this persistent layer of colder air right along the coast, and you have a lot of clouds in that layer today because you don't have north to northwest winds at the surface mixing out. You have some northerly winds, slightly northerly winds aloft here at the 500 millibar level, but we really don't have a lot of winds at the surface. So that's allowing somewhat of a persistent marine layer at the coast. So low clouds push inland in the morning and then usually retreat to right around the coastline during the day. Sometimes certain coastal areas won't clear during the day. It really depends on what the wind is doing. But it also helps keep the coast nice and chilly for most of our summer here in California, for instance, which is like gives us that natural air conditioning. So the next thing we want to look at here is the what we call the Fort Ord Profiler. This is a very useful tool for figuring out what the height of that marine inversion is, because with our weather out here, you have like if you have a little trough of low pressure come in aloft, you're gonna have that marine layer. It's going to expand. You're going to have a deeper inversion layer. If you have more of a ridge of high pressure, even if it's a flat ridge, you'll have the marine layer at a lower elevation. So let's just pick out here. You see these blues, these purples and blues? This represents cold air. And the orange and red above it represents warmer air. So by looking at this, you can clearly pick out. Now this goes, time progresses from right to left on this, okay? So it shows you down here, time increases to the left. And so you're looking at from 5 a.m. yesterday morning to the latest data we have, 4 a.m. this morning, if I draw a purple line here where the inversion is, you'll see it's been pretty steady, right around maybe 1,200 to 1,400 feet here on the altitude scales. You can see that's indicative of a flat ridge. You're going to have a well-defined, solid, but relatively shallow marine layer. If we had a sharper ridge, this would be even more compressed. I've seen it where it gets completely wiped out, where there's no marine layer at all, and the warm air here makes it all the way down to the surface. That's not what's happening today. When you have a low pressure system aloft, particularly if it's a stronger one, you can have the marine layer deepen, and depending on how much it deepens, like you can have it deepen. I've seen it well over 2,000 feet. I've seen it close to 3,000 feet, this line sometimes, when there is low pressure aloft, and that low pressure is causing the air to rise, and it's lifting the marine layer. And a lot of times when that deepens enough, it'll actually mix out. You'll have, it'll allow the solar heating that comes in to actually mix out the, see, you get this solar radiation, and then you get downward radiation, and then you have upwelling infrared long wave radiation that comes back up. And when the marine layer is deep enough, it is able to mix out more easily. Because when it's shallow, like a day like today, when it's more compressed, it's gonna have a harder time mixing out, because you have sort of an atmospheric lid here. The warmer air above, because it is lighter than the colder air below, this colder air gets trapped down here, and it's hard. It makes it harder to mix out this inversion, particularly when you have pretty strong winds. See, these barbs here indicate, see, that's like 20 knot, if I'm not reading this wrong, which I don't believe I am. This indicates 20 knots of sustained wind. That's pretty windy, out of the west, right straight from the ocean. So when you have this constant feed of colder air establishing this very well-defined inversion, the solar radiation, it makes it harder for the solar radiation to heat that up and break up that inversion, because you have a very we have a very well-defined layer, and you have high pressure pressing down on this layer, so it's going to make it harder to heat up the to mix out the marine layer. When you have high pressure, it's harder to mix out the marine layer, and usually when you have a consistent onshore flow with that high pressure, it will stay cloudy and cool at the coast, where it is hot inland. And that's precisely the kind of pattern that we're looking at today. This is what we saw yesterday. This is what we're likely going to see again today. Now I'm going to move on to what are the weather models showing, right? But before I do that, I just want you to understand better what I'm talking about. So I'm going to show an example by looking at what the high temperatures were yesterday. Okay, so we'll look here at yesterday. We'll look at end of the day. We'll look at what the high temperatures ended up being, right? You can see here, look at these 50s and 60s along the coastline. Look at this cooler air. So if I were to draw roughly a 70-degree isotherm, although this is supposed to be cutting like this way, but you're gonna see this cooler air. See, this isn't perfect because you have some values above 70 here, but 70-degree isotherm is doing basically something like this. You also have some cooler spots here. But yeah, you notice that near the water you have cooler air, but you go further inland and you have a lot 80s and some 90s the further inland you go. So you see classic pattern of what I was talking about of a marine inversion. And then a really good way to notice this is you look at this station up here at the top of Mount Tam, 86 degrees. This is the same mountain, but just going downwards to, this is about 1,000 feet, 66 degrees. If you go a little lower, this is the station here is about 700 feet, 65 degrees. Clear inversion layer present. Mount Tamalpais, for you to have an idea, is at 2,500 feet, roughly, the top of Mount Tam. Inversion layer we just saw, it's about 1,200 to 1,400, so this checks out. This is a well-defined shallow inversion layer right at the coast with warmer air up above and further inland. So now that that's explained, we're going to go ahead and look at computer models. So I'm going to go ahead and show you, let's look at the European model for height anomalies. So this is how anomalous, either above average or below average, the pressure heights are at 18,000 feet. What you see is that flat ridging pattern I was talking about actually does spike up a little bit by tomorrow into the Pacific Northwest. You see this blob of above average heights. It's going to be a nice little warm spell for places like Seattle and Portland. Doesn't look like a super intense heat wave as of now, but something to be aware of. It's a little warm spell here. And then you see, as you pay attention off the coast of California, you're going to have some troughing. Here's what we call a cutoff low. Because it's cut off from the mainstream of the jet stream, but it is a low pressure system at that 18,000 foot level. What that's going to do is deepen the marine layer and allow that marine air to push further inland. So as we go into early in the week, Monday, Tuesday, whatnot, you can expect to see more ocean air pushing further inland. Will cool off certain areas. Now I'll just go over temperatures real quick because I know this video is getting pretty long. So let's look. It's going to start out zoomed in at San Francisco, but I'm going to make it for California. Give you a bigger picture here. And so you can see what's being projected today. Temperatures well into the 100s for inland areas, Central Valley, per the National Blend of Models. You're looking at 104 in Redding. You're looking at just about 100 in Sacramento. Down towards the Palm Springs area, you're looking at 110. Very hot down there. Coastal areas, as you would expect, cooler, 60s and 70s across the board. Further south, you got a little warmer. The water is colder. Further north, you have a cold current, and you also have a lot of upwelling that happens here, which is when the winds interact with the coastline here. And they actually shave off the upper layers of water, which are relatively warm, and they upwell deeper, colder waters from below, and that's what makes it so chilly. Look at these water temperatures, chilly water temperatures along the Bay Area coastline, which is going to allow for that fog, for that chilly fog, to really have an impact in places like San Francisco and Monterey, the immediate coastline as you go south even though waters aren't as cold down south, so you would expect you have more like 70s at the coast instead of 50s and 60s like you have further north. And then, so let's go to Sunday. Okay, Sunday is even a little hotter inland. You see places like Medford, Oregon could hit 100 degrees tomorrow, up from 91 today. So you definitely see that heat really pronounced inland. See, coast remains cool. And then as we go into, here's Monday, here's Tuesday, here's Wednesday, you see some cooling starting to happen inland too. It's not very significant. Particularly Monday to Tuesday is when you really start noticing that. You're still gonna see like upper 90s really in the Central Valley, although it's not in the hundreds anymore. So you get a little bit of relief, but where you'll really notice this is closer to the coast. You're gonna have that cooler air able to push a little further inland. And then looks like significantly cooler. So that troughing was probably gonna hang. It's probably gonna hang around a little bit because then you go down to just about 90 in Sacramento, down from 100 a few days earlier. Only 90s for the Central Valley. It's actually quite comfortable for this time of year. So this kind of gives you an idea of what happens when you have this yin and yang, or push and pull, if you will, of the high pressure and the low pressure, and how that changes the depth of the marine layer and allows the marine air to push further inland when there's lower pressure. But when there's higher pressure on a day like today, you see the marine air is a lot more confined to the coast. Anyways, I think that's going to do it for this video. It gives you a general picture of what we're expecting, at least in California. I'm based in the Bay Area, so I tend to focus on the Bay Area, but gives you an idea of what we're expecting for this week. But I'll just do a quick look at the Pacific Northwest, because looking like we might have some heat up there. So we got Saturday, Sunday, Monday, Tuesday. Looking at Monday, it's looking pretty warm. We're looking 83 for Seattle, 92 for Portland. Willamette Valley well into the 90s here. So you do see some heat. So you see some more. It's not extreme heat by any means. It's not a major heat wave, but it's definitely a little warm spell. Coast will probably remain relatively cool. You're looking at maybe upper 60s for most of the Washington and Oregon coast. And then as we go through the week here, it starts to cool off a little more, even for Oregon. Probably that trough I was talking about earlier. 4th of July looks actually not bad. 70s for Western Washington, 90s for Eastern Washington, mostly 80s for Oregon overall, and then you're looking at maybe about 90 for the Central Valley, inland locations of California. Coastline could be chilly, maybe a little bit of fog and clouds, can't rule that out. Have to keep an eye on that, but yeah. Thank you for watching. I know this was longer than I hoped, but hopefully there's a lot of information there. Hopefully you were able to get a good picture of what we're expecting this week. So thank you for watching, and I'll see you next time.